you guys not sure, we should talk about that one equation, okay?
I don't know what you said other than stuff.
Alrighty, folks. So the question is, what is the significance of a log function?
Nothing.
The base is 10.
Oh, come on
if
now.
There's no base.
That's true. Yep. You assume the base is 10.
Significant if I do say so.
It is significant.
If I do say so myself.
What does a log function look like on a graph? Just
Like
draw it
this.
with your hand.
It's like,
I think it's kind of like, doesn't it go like up and then across?
Is it that or, oh, what's that? Is that E?
Yeah, that's like an exponent.
E is like
I think this is, log is this.
Oh, yeah,
Oh. I was watching at home. It's like this.
Yeah.
I feel like it's like a, that's our AP Physics workout there.
No, it's like
Do the log
Zumba.
function.
In Zumba.
Okay, so
Feels burn.
what's the question?
So log
What's
functions,
the significance of log?
log functions look like this.
Wait, is Kylie on?
Yeah.
Hi, Kylie.
Hey, Kylie.
Five,
He came to it today.
So log functions look like that.
Other than the
And
fact
so
that-
the significance of a log function, listen up for a little bit, guys. Significance of a log function is just in its slope. Just like with everything else, when we're doing derivatives, we have to pay attention to what the slope is at a certain point because that would be its derivative, which is what we're going to be figuring out today with log functions. Just the tangent line on its tangent line on the function is fine. This isn't this. I'll just tell you right now. This isn't going to be one of the questions on the semester final. Yeah. So I'm trying to figure out a way to work log functions into a question, and so that's what I got for now. Yeah. Well,
Log of x equals y by derivative.
yeah. I should just do a trivia thing. I kind of liked Potter's thing with what is the base if it's not listed. Maybe I'll do that. Okay, so worksheet number 4. I think I'll start just by putting the answers on the board, and you can check to see how you did yourself. And then if you want to talk further, we can do that.
I'm like 87.4% sure I got number 8 wrong.
87.4.
Where?
You sent it with your phone.
Here.
Yes. Yesterday.
No.
Because you said, I want to check them tonight so I know how
Forgot
bad
to
I
take that
did.
picture.
I don't think you actually said how bad you did, but I just added that.
You said I did that. What are we doing today?
Math.
Yep, after we're done with the worksheet 4, then we're going to learn about taking derivatives of log functions. And not just any log functions. Most of the time it's going to be natural log functions.
Because
So-
we're
So,
going
you
so
want us to
much
use
that would
D?
make sense.
Yep.
No, it's log.
Potter. Nathan, calm down. Okay. I didn't mean to make you too
I want to build a log function, Kevin.
excited. I have this down and I'm sitting by myself like this.
Yeah, he needs to have it on.
Hey, don't I'm not. It's on. Don't worry. It's on. It's on.
Hey, distance.
So let's
It's on.
Source of distance.
So this one is number 4, right over here.
I see.
Bro, it's like
You see what I'm doing here? That's number 3, up there.
What? Ah,
Right,
It's going right over Potter's head again.
right there is number 3.
What?
Look at
You
the.
can't see it on the screen.
Down here is number 2, or number 6. Number 6 is down there.
What?
Because of the video,
Potter, you're the
Only look at this screen. Ignore what he's doing.
you'd have to just look at that.
Yeah, that's what I'm looking at.
So, like,
Potter's
number 3 is up there.
Oh my goodness.
We're a very intelligent class, can't you tell?
Oh yeah. Just remember, this is recorded forever.
I know, when you say that, it makes me feel really dumb.
When they go like all virtual, like no teachers, this is what everybody's going to be learning from.
Oh shoot.
I feel so bad for you guys. I am sorry.
Okay, I'm just gonna.
I promise you, I become smarter.
I'm just gonna tell the kids not taking AP physics.
Yeah, just don't do it, guys. Drop out while you
If
still
I'm
have
a
it.
doctor,
It's the
trust
hardest
me
class.
that I have studied a lot.
Is this the hardest class?
I'll tell the kids it's the hardest class, and the teacher is good, but no. Just don't take it.
But no.
Don't take it.
Yes.
Give me service hours and I'll edit out all the funny parts.
But then it also kind of ruins the experience.
Yeah. We got to be able to look back at this 20
Yeah, if they're
years
sitting
from
at home by
now.
themselves, then they.
Oh my goodness, our class reunions, we're gonna have like so much stuff recorded. We'll be like, oh my goodness, guys, remember when we were virtual and now that's like the normal thing to do, guys? And now it's like, look at our kids, like.
So,
You guys are all gonna be
So
at a reunion-
anyone doing illicit drugs?
You guys are all gonna be at a
Stop
reunion together, and I'm gonna
doing
just be
that.
sitting at home.
Well, and then you'll be at your reunion the next year.
And you guys
Alright,
are gonna be sitting
okay.
at home.
So make sure you're taking a look at this. You've got 1 or 2 more minutes to check your answers, and then we'll move on. Onward and upward.
What if math changes?
Turns out 1 plus 1 does not equal 2. Oh yeah, come on up as close as you need.
What if numbers don't work in the future?
Change our math system from 10 digits to binary.
Yes.
No,
Like, what if
change
that
it
is like
from,
what
It's
happens?
all fun and games. but it's
Also, can we
binary.
just change to the metric system? Like, please?
If it hasn't happened by now, it's probably not going to happen.
Yeah.
Can't we just be normal?
Why can't we?
My normal
We are friends.
my normal.
Are we not friends, Jaden?
No, we're Americans. Can't be normal.
I kind of like the Fahrenheit scale, though. Like, I don't want there only to be 20 degrees between freezing and room temperature.
Fahrenheit? I hate Fahrenheit.
Really?
I get used to Celsius a lot.
Yeah,
For like 15 years, 16 years of my life. So it's
sure.
really hard to get it over.
Mm.
Nice. Sure. Coming on September 19th.
Interesting.
Shrek Fest online.
Oh my goodness. Are you on a website that you should not be on during school?
Yes, he's on the black
It's
website.
also the bottom part.
You're on Twitter, so.
Right.
I love Twitter.
Yeah. Well, I'm gonna check mine. I checked mine yesterday.
Did you guys know the Twitter mascot is named after Larry Bird?
No.
The Twitter mascot is named Larry.
You guys know who Larry Bird is?
Basketball player.
I know it.
Like, how do you write that nice?
If you want to see his stats, they're behind my chair there. Big Larry Bird fan.
Like, Mr. Hathaway is handwriting awesome.
But I know Larry Bird.
So let's do number 8. 8?
I heard 1 for
Number
number
8,
8.
cosine 10 times sine 1
Look at how nice this is.
Oh, should I move this down to number 8 here? There you go.
That's what I had, right?
I don't
I
remember.
mean, I don't have brackets and stuff, but it makes sense.
Yeah.
I like to add in a little dot.
I'll walk through number 8 after you get a chance to take a look there.
Oh,
I did.
Figure
I
it
did
out.
6 really well.
Yeah, don't make 6 more confusing than it really is. You're just, your inner function is the exponent up there, so.
I think it was.
Okay, let's just walk through number 8 real quick because it's a beast. So,
Dude, I did number 8.
sine of tangent of square root of sine. So, chain rule is derivative of the outer, keeping the inner function the same, times the derivative of the inner. So the outermost function is sine. Therefore, the beginning of this is going to be taking the derivative of just the sine function, and you've got cosine, leaving the rest of the inside the same. Now, because we got to use the chain rule, we have to deal with the inside of the function here. So we have to take the derivative of the tangent of the square root of sine x. And so the outermost function of this is tangent. The derivative of tangent is secant squared. So that's where this comes from. Of course, we have to keep the inside function the same, which is why this remains the same there. And then finally, we have to multiply all of that by the derivative of the innermost function, which is the square root of sine of x. So, we rewrite that in a nicer way, sine x to the 1/2. Pull out that 1/2, comes in front there. This turns into negative 1/2. And then finally, we have to multiply that one more time by the inner function of the innermost function, which is sine of x. And you get the final big answer.
It's all went way over my head.
This is, don't sweat this one. I mean, this isn't going to be something that's on the test. It's just kind of fun if you can keep up.
The last
Stop.
cos
See,
come
I can't.
from? No, the cosine is supposed to be from the inverse of the sine. Where is that sine coming from?
From this one right here, because square root of sine x, this is a chain rule within the innermost function that we have. So we can't just take the derivative of sine x, or square root of sine x, because it's square root, the inner function of this innermost function is sine x.
Oh.
So yeah,
I
this
see.
turns into this, and then this 1/2 has to come out in front. This turns into negative 1/2, and because there's an inner function remaining, we have to multiply that by the derivative of the innermost function. But yeah, just don't sweat this
That's how
one.
you checked it 4 times.
If you're okay with the others, you're in good shape.
And then I have just a quick question, because, I mean, the half and exponent makes sense, but sometimes I like to just leave it under a square root. Is that fine?
Any final questions on this? All right, I'll come around and get it, and then loosen up your hands and fingers and get ready to take some notes.
If either one of us gets corona, we both have it. Like, it's just.
Whoa. Hey.
I feel like if
There
only
are, like,
one of
three
us
people-
got it, I would be impressed.
I would be impressed as well. Like, there are 3 people, like you, Hannah, and Brian. If I were to get it and none of you guys would get it, I'd be impressed. I spend a lot of time with you. Maybe makes sense. I spend a lot of time in real circles. Yeah. I know that there's
As long as our football player doesn't
I think you have way too much fun with your camera.
Look it! There he is.
I have no idea what you're talking about.
Mr. Nickel had to record his 7th hour AP Lit today, which means he recorded his crazy class. So he was like acting out, getting shot, and like getting electrocuted, and like all these different things. It was so good.
Awesome.
He records 5th hour. He usually records 5th hour, but he forgot to today. So then I asked him, "Did you forget?" He was like, "Yeah, we have to." Record 5th hour."
Now there's a video that all of a sudden has different voices and a lot more noise.
Yep.
Huh.
I feel so bad.
I
for
feel
people
bad
that
that
watch
Mr.
it.
Hathaway only has one option to record because we are crazy.
No, you guys are fun.
We're nothing compared to the AP Lit 7th hour.
You don't want to know if you would.
It's
I'm not in that class.
I'm
It's
not
bad.
either. I'm not either.
I'm in 5th hour.
Well, I'm not in AP Lit.
I know it's crazy. You got Mason, you got Abby, I think you got Carly.
You're a piano. Oh wait, no.
Hannah's
that's
in.
okay.
But we have Abby, Carly, Mason, me, Alexa, Mariana,
Miranda.
Whoa, all the
Piper, Greta.
Oh my goodness.
Like,
All the
That's-
people that when you put together, they can't help but talk.
That's how you take derivatives of log functions.
Okay.
when I see cursive in the middle of nowhere, I'm like, what?
Yeah.
It's natural.
That's right. My
Oh, I
natural
got it.
logs are cursive because if I go like this, they're going to be like, what does 1n mean?
Well, why don't you just
I
say
have
the
heard
person
some people say
L,
that in the past
We'll say
2
what?
weeks, and it made me sad.
What'd you say, Katie?
I've heard people say, "What is the one N?" in the past
Right.
tense, and it made me sad.
Yeah.
That's okay. The other day I called it incline.
Incline?
I was in calculus and I said incline.
What's like 1 over what x?
Like, it's an L. It's not even, like, don't make sense. It's okay.
How did you draw such a straight line? Time out.
Also,
Hey,
wait.
look at that line.
It's pretty good till it gets about here.
75% of it is
No, a little
amazing.
bit
Yeah.
further. Like,
It's the little things.
A little bit higher. Because there's a little bit higher. A little bit more.
Okay, now it's not even worth it.
No, right there.
ruined it.
Right where you were.
It's
Right here.
It's good. It's perfect.
Okay.
It's perfect.
Oh, this is good and this is horrible.
It's perfect.
So like we're really precise.
It's probably just my eyes, Mr. Hathaway.
On out.
It is dressed.
It's my eyes.
It's
What's
perfect.
the last name?
Well, then your eyes hurt my heart.
Austin, you
I'm
give us
sorry.
your freshman year?
I will tell them. Are you talking about Gonzalez Clark?
Yeah.
All right. So if we have to take the derivative
It's like that kind of energy.
of the natural log of sine of x, we have to just follow these rules. And typically you'll be dealing with natural logs instead of regular logs. So if the derivative of natural log of x is 1 over x, then the derivative of natural log of sine x,
It's sin x. Of 1 over x.
Whatever cosine x.
Whatever.
1 over sine x, but what do we have to do also?
Then you have to do the
Yep,
sets.
derivative of sine, because this is also a chain rule. Because the sine function is inside the natural log. So you multiply this by the derivative of sine of x, and you end up with cosine x over sine x, which I think is inverse tangent, right? Cotangent?
Not, well, no, it would be inverse. It would be cotangent. Because tangent is sine over cosine.
Yeah. So if you flip it, that's not inverse tangent? I don't remember.
That would be cotangent.
Okay.
Tangent.
So it's cotangent then.
Tangent
Right?
is sine over cosine.
Am I
So if
wrong?
you flip it, it's cosine.
You
Okay.
guys are
I
arguing.
didn't write
So it's
it.
cotangent then.
Smart.
Let's do another example.
Oh, what? Uh-oh.
Yeah, I'm trying not to write over there because that might be hard to see in the camera.
I'm awful.
It's like a 360 degrees class. VR.
No, because I'm going to see us.
Maybe you need to take the derivative of this function.
What if we got a camera like dummy, so it's like a person, so they're like sitting in the classroom while taking it, and then you like turn and see the other students?
Like a robot.
If you can figure that out, more power to you, and we'll hook it right in. Placido,
Half the end.
of this,
Yes.
what's the answer?
1/2 x to the negative half.
Not quite. We also got to do chain rule in this
It
thing.
was a good try.
That's right.
You're right for the first part of it. So because we're starting here, when we take the derivative of this function, first thing we'd probably want to do is just rewrite this so it looks nicer. This is natural log of x to the 1/2. So chain rule again. We got to take the 1/2, bring it out in front. One half times natural log of x to the negative 1/2, and we got to multiply that, of course, by
1 over x.
times the derivative of natural log of x.
Okay, so I know when it gets more complicated, you're going to want us to write the derivatives out because it's going to get a lot. But for right now, can we skip that?
Yeah,
I know it's a
I'm
bad
just
habit.
doing this so that everybody can follow.
I know it's a bad habit.
So that's that.
Is there a chain rule where you divide? Like,
No.
No?
Not that I'm aware of.
It's
Hey, you can discover that.
No, that's
No,
okay.
thank you.
I don't think we want
And
to
you
deal
would have
with
to
that.
record all these videos again, and I wouldn't want you to do that.
Well, if you discover it, you'll be the one recording it.
Ah,
Because you'll be the famous one.
yeah, that's why I won't discover it.
12?
Or discover it. Tell it to someone.
You have to divide it. You remember like 12.
Hey, Katie.
Like,
Yeah.
technically
So
discover
how
it.
about this thing where you divide? Like the chain rules, but you end up dividing. Oh, you wanna discover it? You just said the text. Yeah, but you're gonna be the famous one. I'd rather not. Exactly. I'm the one planning. What about Ender?
I don't think that will make a person famous.
You would make it
No,
into
do you
AP.
Your name would be in a textbook.
No, do we remember who made the multiplied one first?
Mr.
Chain.
Chain.
Yeah, you know my dad Pythagorean.
Paul Chain.
He's famous.
What's his name?
A
It's like
squared
Paul
plus B squared
Davis.
equals C squared, if you know what I mean. You know what I mean? That triangle? Yeah. What's that called?
The last time we can tell you.
We don't want to get it.
All right. Let's just go through this one together.
You good?
No.
So,
Okay.
because we're not going to be dealing with regular log functions all that much, we'll just kind of plow through this one and move on. So again, you're just following this rule when you take the derivative of a regular log function. You take a 1 and you divide it by x, whatever's out here. That comes out front. Then you take the natural log of whatever the base is. So that's what we're doing over here. So if this is our function, we want to pull out the x, which is the 2 plus sine x in this case. And that comes out in front. Natural log of whatever the base is. The base is listed as 3. And then because we have ourselves an inner function inside this log, we have to take the derivative of that via the chain rule. So, derivative of a constant is 0. Derivative of sine is cosine. Voila. I just know one of these times when I back up, I'm just going to fall backwards. And that is going to look hilarious on this camera.
I wonder how many like videos for AFD or something have been created because now everything we record.
Right.
Someone just needs to live stream Harvard's lectures in the front.
Honestly, though,
All right.
Free education.
This next one, I'd like you guys to try and just verbally tell me how it works because it would be a long problem. So let's just see if you can do that. If you're okay with it, then we don't have to go through the entire thing.
I think we were writing a lot of notes today.
Not a lot.
Oh. I'm sorry, David.
You can get stretches for just a little bit of work too.
Oh, that's true. You don't want to get injured.
He's just looking out for us. He didn't say there would be a lot.
did you take the reciprocal thing?
The derivative of that.
You will.
Opposite reciprocal.
Well, you would end up.
I know, but you can't say reciprocal.
So can someone tell me what step 1 would be here?
Yes.
Doing the derivative of the ln and leaving the middle as the x. So it would be. Well, you would end up with radical x minus
Oh,
the
it's first
out.
the-
This is where I get confused, Katie. You know what I'm saying? Because when you because it would be another 1 on top, but you'd be dividing that by there's a rule where it brings on top to bottom. Like,
Yeah. So this is the sort of thing where, again, we do have a chain rule. This is our inside function. But, I mean, the outermost function is natural log. So because of that, we got to take the derivative of that first. So derivative of natural log is just 1 over whatever that function is. So
just
you would
flip them.
begin, by just flipping them.
okay.
Because 1 divided by that quotient is just going to be square root x minus 2 divided by x plus 1. That's how you would start. And then after that, you would do the quotient rule because you got to take the derivative of the inner function.
And you would take that of this initial one, right? It would be where the denominator is still the same. Not
Yeah.
as if it were flipped.
Right. The one that's flipped is something you multiply the rest of your quotient rule by at the very end.
Gotcha.
Yep. don't know why I need to go like this.
Well, you see me
It's
talking
fun.
with my hands like this.
Practicing
so
your
it's
blocking.
Okay.
Practicing experience.
I'm just gonna probably do the same thing with the next one. It's the same thing, just with product rule.
Oh. I don't like that. I can feel it. I don't like that.
So someone tell me how you'd approach this. Placido.
So the outside function is LNX, right? The entire thing is the outside function.
What do you have? Well,
There's not.
Two separate.
Yeah, these are just two separate ones.
Well, you have to
You
take
have
X
to
to
cut
one
it
half
out.
for one.
would you start
Here.
the product?
Start with the product rule. So you separate the two, and then you do chain rule for the square root of x when you have to do it inside the product rule, and then you do 1 over x for the derivative of partial 1 of x when you have to do it for the inside the product rule.
That's the idea. So the main thing is the product rule here. You've got two separate functions. You'll be using the product rule in order to figure those out. Derivative of natural log of x, of course, is 1 over x. So 1/2 of it is going to be square root of x times 1 over x. And then the other one that you're adding to that is going to be the derivative of this, square root of x. And of course, that's equal to x to the 1/2.
X negative.
Yeah, when you derive it. So it'll be this times natural log of x for the second half of your product rule. I'll put the final answer on the board and then we'll call it for this one. This is what your final answer should be. This comes from 1 over x, when you take that derivative, times square root of x. That's what that is. All right, I'll pass out the homework. Do the best you can.
Your mom?
Yes. This is as far as we go with derivatives.
Really?
Yep.
Aw, they were doing fun.
Yeah, after this we start integrals.
Is that the one that made you want to die?
Of course. Thank you.
We're not supposed to know that's like
Are you gonna make us do it?
Not so real. It's time to
Are you
quit.
gonna make us do it and go slow? You have.
No.
Okay.
We're going to do whatever shortcuts we can with integrals,
It's
just like
time
we did
to
with
quit.
derivatives.
we can use our calculator.
That's
You can use calculators to check, but you can't just.
Are you calculating my derivatives for you?
I have a derivative setting, but I have to have all of this stuff to plug it in.
Sarah, did the calculator have an integral function on it?
It does.
There you
Yours
go.
not? Way too much fun. Bye, Kylie.